All right. We're gonna get started on our dice animation. We're gonna trick it out this time. And I actually got the set image function working, and so my previous rant about set image is bunk. So ignore that from a previous video. But other than that, we're gonna have some fun getting this animation stuff going, and of course you can apply it differently. I'm gonna kind of hard code some of this, and I would rather allow for an animation where I can send an image view, an array of images, or an image sheet, a sprite sheet or something that it can run from. What we're going to do is we're going to create the array of images in the game piece. So we're going to actually use our game piece code. Now, one thing when you do your project, you want to make sure that you put your die images in your project folder, and you want it to be the project folder where your IDE is running from. So sometimes it's kind of hard to get it to open up a file that's locally, especially when you're testing from the IDE and testing from NetBeans, because when you tell it to open a file and you don't tell where, you just say, hey, I want this file open, my file .jpg, and you're not telling it to go to C drive, whatever. What it's doing is it looks in the only place that it knows exists, and that's where your executable is running from. So you want your files to be with your executable implicitly, and you would do things like this if you were going to do this for distribution. You don't want C:\/ or anything. You would create a pictures folder, and this means go to the current directory of where the executable is working at, go into the pictures folder, and open up myfile.jpg. You don't want to do it like this. This is just total crap. That'll kill you for distribution when you get to actually distributing your application. You can't do things that way because you don't know where this is going to be installed. So we're going to do it very simply with just the implicit direction, and you want to make sure you check your project folder and that you have your images loading up appropriately. If you need to add your exceptions, do that. Just make sure it's happening. So the actual project folder that we're working on, I called it dice here, and inside of it, let's see, did I get the right one? I'll go to source, and with my main class, I have my die function. That's one of the folders. I think the one I'm working on right now is the game piece one. And that one, if we go into source, we see I've got my images in with my Java main class object here. So this is where your IDE is running from. But if you were to go into your executable and run it into your actual binary portion of this, where it builds it, you would want those files with it too. But we put it here because we're running within the IDE, and it's taking this directory as its default running directory. Okay, so I have some code for you guys to use for this, and when you bring that up, before we do that, make sure you have your project started, and you just basically have a default JavaFX main class with your start function. You have your images in with your source file, and that's going to be just so far. Go ahead and go into the code bits, and what we're going to do is we're going to just grab a little bit at a time from the code bits. First, I want you to go ahead and go into the code bits file, and let me go ahead and bring it up because I'm going to be using it too. Wait, is that one? Yeah, maybe. Let me make sure I'm getting the right one. Oh, okay, that would be the one. Okay. All right. So go ahead and we basically, I got the start. This is the start function. So this first bit in here, grab all this stuff and copy it in. Some of it you won't need. You can take out the import of some of it and get your imports taken care of. you'll need those. You'll need this one too, because we're going to be using our G piece. You can just take, if you did the G piece, some of the G piece videos, you can just take one of that whole project, copy it, rename it, and work with it. So we're not going to start here today. We're going to start with our game piece, and we're going to implement the animation in the game piece. So we're going to start actually in the gpiece.java file. And let's just grab a little bit at a time. We'll talk about it as we go. This one's actually pretty simple. It's not too significantly, it's not full of a lot of code, but we're just going to, just a bit at a time. So the first thing that we need is we need a constructor, and an overloaded constructor. And then let's get that going, and let's get an actual game piece actually drawing on the screen, and then we'll get into animation portions of it. So let's go ahead and grab the two constructors. One of them we're not actually using, so the default constructor we're not actually using. So we'll just add it, but we won't be doing anything with it, even though we should. We would finish this up. Right now I'm just gonna make this one perfect. But this is our game piece constructor. Let's go ahead and grab the other stuff that goes with it. I just want this part right here, and grab these things too. These are what we're going to be using in the game, in the image view. So I'm going to go ahead and fill in the rest of it, which is the actual game piece declaration that extends image view, and then I'm going to go down here to the bottom and close it out. Okay. So I'm starting to have an object. The one thing that I need is my includes. So let's go ahead and grab those. And we're going to be using these guys right here. Okay. Now let's look at what we have. We have our includes. We have our game piece declaration. We have an image for our dice, and it's an image array. And notice how I'm putting it up here so that it's global through the whole object, which is the way you probably should do it. Now, we don't need those. Those are from our last video. But one thing that we are going to be doing is we need to keep track of what image we're on with a counter. So we're going to have that counter. Then we need to keep track of our animation speed. How fast do we want to show our animation? And then we need to have something to keep track of our timing. And that is, when is the last time we did or updated the images? So how fast should we update the image? And when is the last time we updated the image? And guys, this is all done in what we call the epoch time. That is milliseconds from 1970. The epoch time is very special in computer science. It's used a lot. It's especially used when you use like the random function and you need a good seed, like a good seed, a number that's unique and will always be unique. That's why you always seed your random functions with the time now functions with the time now milliseconds from 1970 for any language. It doesn't matter what language you're working with. You seed them with the epoch value, because it's always going to be a unique number, because the epoch is essentially milliseconds from 1970, so it's always fast. It's always going to be a unique number. This is only showing seconds, so there's actually 2 more decimal places out here for the milliseconds. So essentially 1,000 milliseconds is 1 second. So if you got 500 and you're setting up for 500 milliseconds, that's half a second. So this is how we keep track of all our timing, and I can tell in my animation when 5 seconds has elapsed or 1 second has elapsed, and that's by getting the epoch timestamp, and that is just literally milliseconds from 1970, and it's a huge long number, and we actually got to use the long data type for it, so we have more bits to store it. And that's why we have the long declared up here. So that timestamp is, I'll tell you what, you've never gone crazy until you've had to look at timestamps in milliseconds in a log file and try to find out what day, time, and month it was. And that was back before they had all the algorithms to do it for us, like I just showed you here. This right here, they have the algorithms built for us to go from this millisecond value into hours, days, month, and year, and the human dates. But it's not like the human date on the system. No, it's not. It is literally one huge number. That's how time is told on a computer. It's freaking ridiculously awesome because it makes time so simple. You just one number and you got your time and date. That's it. And so we do our timing with that, and we also use it to seed our random functions. So we're gonna take advantage of the epoch time today for our animation timing. And you know, Java has stuff for doing animations. I don't care. I don't like to use their any third-party crap because it takes me longer to learn how to use their stuff than me to build it myself. But that being said, sometimes you really can't get into reinventing the wheel. However, part of instruction, you've got to show how the wheel was built. So I mean, really, come on. So we're gonna build a wheel today. Let's go for it. The next thing we're going to do is we're just going to add an empty pointer. This is just a pointer that points to an array of pointers that points to an actual image. So that's just going to set up the initial first pointer. And I declare that, but I haven't instantiated it yet. I'm going to actually have to instantiate it. And that's the first thing that we're going to do. So we go down in our constructor, and we've got this that we have for an image. We're going to comment this out for now. We don't want to do any of this stuff yet. All we want is let's just get our image view on the screen first, and then we're going to start playing. Okay, so we should have a game piece that is, here. It looks like we have an image that loads up that we're going to draw. We're going to actually change that. That'll be die1.png. Let's go ahead and set that to die1. We actually don't need to do it from here. We can do it from our array. So we're going to actually change it again. But that's fine for now. Let's go test it out. So let's go ahead and go to our game piece. And what we're going to do is start bringing in this stuff a little bit at a time. Nah, let's get greedy. Let's grab the whole thing. Yeah, why not? You pretty much got most of it. So let's go up here. And notice I'm just going to grab the whole class and go all the way down and grab the whole thing. Copy it. And then we'll go over here and we will paste it over. Notice how I put root up here as a global. That's not needed for this example. We could actually put this back down here in the start function. That's fine. I'm just going to leave it the way it is. It's not hurting anybody or anything. And we're going to comment out this first piece start animation function. We haven't built that yet. So now what we should have is an image the instantiation of our image piece called first piece. This is all from previous videos. And then we show it to the screen. And what I want is just, hey, am I drawing the video? Or not the video, but the image. So we got a few errors that I'm going to get into here. It looks like it doesn't like the start method for some reason. Okay, it looks like runtime was okay. I'm going to delve into what may be causing this issue, and then when I come back, we'll discuss it and go through the steps. Okay, well, okay, yeah, obviously. So I did a hack and slash. I went in, I just commented out everything, and I found that when this line run, it was dying, and obviously, of course, that's got to be something to do with some code that I changed. So then I go in here, and sure enough, I look at my image, and I'm loading in PNGs when I have BMPs. So that used to be BMP, guys. All right, that's why you should add your exceptions, by the way, so that you can detect when this happens, and you're not like, oh, it's all of a sudden not working. Why? I got to resort to hack and slash and comment out everything and bring it back. Okay, enough of that. Now we're ready to test. Okay, we have our image and it's up. The next thing that we want to do is animate it. So to do that, what we need is an update as a timer, essentially. A timer that runs as fast as possible, which I'm pretty sure is the default. I'm not for sure. But you can set the elapsed time in milliseconds for any timer. But what I'm trying to show you to do is an animation that is not dependent on the timer. In other words, the loop is more like a game loop, because if I was doing an animation, I would do it in an update function out here in the main, and then I would update all my animations from one update function, one timer. You can build a timer that elapses every second or every 5 seconds and changes the image, and you just do that every time the timer ticks. That's totally one way of doing an animation that's even easier than what I'm showing you. What I'm showing you is how to make the timer independent of the animation. So you're not using the timer to do the animation other than using it for timing. We're going to use it for just timing. That's it. We're not going to use it for saying, hey, run this timer every 5 seconds, and when the timer runs, change the image. We're going to say, no, run this timer as fast as possible, and I will detect when that 5 seconds has elapsed, and I will do what I want to do. So this is full automation. We're taking full control of of everything and just making it ours. So that's the direction we're going to head into, and maybe towards the end I'll discuss a little bit on the other way of doing things. So let's go ahead and go look at our timer code that we're going to be implementing. And that's going to be just like the things that you've already worked with, the same type of timer code. And we're going to put it in a special place. But what we're going to do is let's go ahead and grab this update function while we're at it. Let's grab that update function because it's real close. And you'll notice that I'm going to put the timer instantiation above the constructors, or the timer declaration and instantiation, because it's both, above the constructors. And I put my update function above the timer because it calls the update function. Okay, now what I want you to do for now is just this. Comment all of this out, except for the first line. Okay, we just want to check to see if our timer's working and what it's doing. And what we can do is we can just do a simple system dot out, I believe. Sometimes I just writing different languages all the time just drives me nuts. Right here. Now we're just going to print now, and I just want to see what it is. Do I seriously have to Google how to print? Yes, I do. Dang it! I keep forgetting this stuff. Oh wait, no, it's lowercase p. Yay! Okay, now good thing I don't have to do the Google. All right. So this timer we're going to implement, and it defines it and instantiates it at the same time, and we're doing that in the level for the whole game piece. So I'm just telling it to run as fast as possible, and I have not started. I haven't told the timer to start animating yet. That's only when we want to control the animation of the timer. So this update function will run when the timer has been started, and it'll stop when the timer has been stopped. So then you're saying, well, Mr. B, how do we stop and start the timer? Well, when we start and stop the timer, we want to give it information like, hey, how long should you take before you switch images? And we're going to do that in milliseconds. So let's go to our code and grab that out. And these are the two functions that we're going to use. And they are the start and the stop of the timer. Now, one thing that I want to point out is that animation speed variable is going to be in milliseconds. And we're setting that when we start the timer. And when the timer starts, remember, we're not doing it for any specific elapsed time. We're making it run as fast as possible. And then we stop the animation. So that pretty much does it. We've got our timer. We give it the function that we want it to run. We start the timer. And when we start the timer, we don't really give it an elapsed time, because you could actually do this with the timer timing instead of making your own timing. You could set your timer for an elapsed time of 5, and it will call this update function every 5 seconds. And then you don't have to look and do much of any work to change the image. Actually, you know what? We might end up doing that. That might be a fun little extension. Okay, let's go ahead and we have our start animation. Let's go ahead and test this right here. This is all we care about. We're just trying to find out, hey, when should I change this animation? And then we're going to get into getting the actual animation to change. So let's go ahead and go back to our main class. And what we're going to do is our first piece has instantiated. We're going to go ahead and just start the animation. And we're going to give it 100. So it's going to be, we're going to give it 500. So every half a second it's going to run. And every half a second, we're going to see this output in our console log. So we should have milliseconds. It looks like maybe the print function might be dying or something. But yeah, I think the print function died. Oh no, it's there. Look at it's just going crazy. Okay. Oh, I should have done print line. Okay. Yeah. All right. Yeah. All right. You know what? I could probably just do this. Yeah, I could probably just do that. Just throw in the new line into the output. Okay, maybe this will make it behave a little. There it is. Okay, so this is the epoch value coming. And you see our output right there. And that's what we're going to use for our timing. So I'm going to go hit stop here. And before we begin, we've got to actually finish our image array. We've just declared the pointer to it. Let's go ahead and instantiate it. So we're going to go down here. And we're going to instantiate the 6 images. And then for every image that we have, we're going to instantiate the actual image. So this just sets up the pointer to the array of references that references the actual image. And this is the array of references where we actually instantiate the image. So when we instantiate the image, it returns the address back to that variable. It just holds the address of the image in memory. That's all it does. And so now we've got access to our dice as an array. And that's going to make it, that's better to do it that way than some of the other ways that we've been doing things through some of the videos. Just because you don't have to use the new all the time. And when you're doing like games and stuff, it's really important that you never use new. You want to pool all your memory. You don't want to use the new in a game loop ever. And anytime you use the new in an update function, that's a finger breaking offense. So that's just, you know, hey, pool your memory when you can. So we're pooling our memory. That's what we're doing here, is pooling our memory, and we do that when it starts up. And then when we get into our timer, we're going to use that pooled memory. So now we have our images instantiated, and our dice image is global throughout our whole object. And now what I'm going to do is we are going to get the last bit. And then we're going to test it, and then I want to examine it and kind of give you an idea of how this kind of works. So you get the current timestamp, and you always keep track of the last timestamp. Now you notice that what happens is I'm looking for when 500 milliseconds has elapsed. That's my animation speed. So my animation speed, if I want it to be 1 second, I'll make it 1,000. If I want it to be 2 seconds, I'll make it 2,000. So what I do is I say, hey, take the current time, subtract it from the last time that we've updated the image, and notice how I'm updating that here. And if that number is greater than 500, that means 500 milliseconds has elapsed. Update the image based on the counter. Update the counter. If you go beyond the 6 dice, reset the counter back to 1. And then go through. I think there might be a fence post here somewhere. I think that might be needing to be greater than or equal to. You guys might want to play with that. I think there's a problem there. It might not be rolling the 6 dice. That's okay. You guys can fix it if you want to. I'm not gonna play too much into it. Let's just run it and look at what it does, and then we're gonna set a breakpoint. Okay, so that's half a second. Oh, the 6 is working. It's the number 1 that's not working. Oh, wonderful. How the heck did we lose number 1? Okay, yeah, seriously? All right, you know what, guys? I'm going to leave that up to you guys to fix and play with. I don't want to mess with it. Let's set the debug here and just look at how this update function is running. Okay. Oh, I didn't hit the debug. I got it. Okay. There we go. Okay, so we get the timestamp, and then we take and we this is the first run, so timestamp, the last timestamp is going to be 0. So it's going to immediately update. And then it sets the last timestamp. Now, I'm going to set the breakpoint for here. And what I'm going to do is I'm just going to hit continue here. And it's going to continue throughout my function call. And we should be able to catch it onto the second call of the update function. But we only will catch it when it actually runs true here, so we can look at those numbers. So I'm going to hit play here, and there we are. Set image. Counter is, oh, that's why. We immediately, okay, we'll play with that later. So I do a set image from the counter, the dice array, and then I update the counter. Yeah, I think I know how to fix that problem. But you can see here that the last timestamp is this huge number, and the current timestamp is this huge number. And what you can do is you can just select that guy, and let's just add a watch for the whole thing. Now minus last timestamp. And we see that now minus last timestamp is 0? Interesting. Oh, that's because I went outside. We're going to have to hit play again and run at it and look at it again. Okay, now minus last timestamp is 52,000. And that's because I'm in the debugger and it's it's taking way longer for it to, do. If we weren't in the debugger, the timestamp would be more of the 500 that we're expecting. But since I'm in the debugger, the timestamp is messed up because I'm sitting here doing nothing, waiting while the milliseconds are marching on. Okay, so here we go, and that's kind of how it works. You set the speed and you take your timestamp. Now, let's look at this, and I think we need to do this. I think we need to take this guy right here, put him down here, set this guy to 0, and say is greater than 6. I think that'll fix the error. Let's just double check right now. Nope. I'm going to leave it for you guys. That's a fence post issue. It's a good exercise for you guys to play with. Try to get the number 1 showing, guys. All right, let's go ahead and get into... we've looked at how it's done. You guys have a working example. Now I want to show you how to do it the simple way. And maybe you might want to consider for this type of behavior, I'm showing you how to do it like the game loop way. And you wouldn't even have your timer in here. You would have it outside. But if you were to do this a little bit better than this implementation, you wouldn't need this crap. You wouldn't need this crap either. Or, yeah, you would still need your counter. You wouldn't need this or this. That's all we would need. Okay, because here's what we're going to do. We are going to use the timer for our elapsed time instead of doing it ourselves. Okay, so yeah, I've shown you how the wheel is built, but let's not build the wheel now. Let's just use the wheel. Well, this is another example of that. There's actually animation stuff out there, that is already built for you to use, but hey. So what we would do here is instead of having the animation go as fast as possible, we would tell the animation, the timer, that our elapsed time is speed. And we would no longer need that or that. We would say timer dot and it's dot ticks. Oh, well, you know what? I'm going to look up how to set the timer interval. It's either interval or elapse or ticks or something like that. I'll come back and we'll continue with that. Okay, well, it looks like the timer for the Java class doesn't have an interval setting. You have to actually set it up special with a schedule, and what you can do is when you set up your timer, you can do a schedule for it, and you send it the function that you want and then the delay. So, yeah, let's try it out. Maybe, I guess, Let's try that out. And what we could do is let's just put it right here for now and just see what kind of happens. And the task is going to be the update. And the delay will be 1,000 or whatever. Actually, guys, this is getting ridiculous. I think what we have is better than what they got. I'm going to leave it the way it is. I think we're good. You guys, if you want to get into doing a specific schedule for the timer, and what happens is all you have to do is you no longer have to do your own timing for interval. Is when you set up with that schedule, that means when the timer runs 1,000 or 1 second has elapsed, and that means that you don't have to look if that time is elapsed. And when the update function runs, you just update it because you know a second has elapsed because you put it on that schedule for that task and delay. And that's as far as I'm going to go into it with you guys, because this video is long enough. And I actually gave you much better than what Java is even capable of compared to, hey, yeah, this is cool, but what you have has a lot more robust ability or capabilities. Alrighty, guys, that's it for today. Thank you very much. Bye-bye.